Good wishes to all of you. Hope you all are staying safe and well amid COVID-19 pandemic. Thank you to IEEE Symposium on Computer Applications and Industrial Electronics conference for accepting our paper and giving us the opportunity to present our paper titled IoT-based distribution and control system for smart home applications. The authors of the paper are follow MD Rukunuzzaman, Mohinul Islam Akash, Mahmuda Khatun Mishu, Wen Shantan, Muhammad A. Hannan, Naushad Amin. The presentation is outlined as the sections: motivation, objectives and outcomes, methodology, result and analysis, conclusion, future scopes. In this presentation, we'll go through one by one these sections to present our work. At first, motivation. The influences that carried out our motivation to perform this research work are the recent development in microgrid system accompanied by solar energy sources and the flourishing IoT technology and its increasing uses in household appliances. Traditionally, AC distribution system is widely used for electrical power distribution, even for the household appliances where majority of modern loads are DC, like DC light, DC fan, DC television, etc. So we can observe now that there are many recent published research work in DC distribution system to power up the DC home appliances from AC distribution. AC-DC power conversion incurs a significant amount of energy losses. As a whole, these losses are not negligible at all. These losses can be avoided by introducing DC distribution with DC chopper to power different voltage level of loads. Internet of Things IoT being introduced in electrical home appliances help make our life more easier and by remote controlling the electrical appliances. It also opens the new prospects in utilizing the power consumption data to predictive control of the appliances, hence truncate the energy losses. Further, introducing sensors to detect the status of the household, ensure efficient automatic control of the appliances, and this process can help us to mitigate the standby energy loss. Run by the preceded background motivations, in this paper a hybrid distribution system and a smart control system exploiting IoT is proposed, with a view to utilizing the resources, reducing energy waste, including standby energy losses. The objective of this research work can be stated as design of a DC and AC distribution to minimize AC-DC conversion losses associated with home appliances. Design of a IoT smart socket with AC-DC outlet. Simulation of Android app-based smart control using ThinkSpeak IoT server. Design of a control model of home appliance, ensuring uninterrupted experience. The first methodology, we want to introduce our hybrid AC-DC distribution system. There is a combined system. In this system, we have 220 volt VAC from the grid that serves the 220 volt AC bus that is used to serve the 220 volt AC outlets of the home distribution system. And here a solar power plant is also attached on the roof. And from that, we can get DC power. And by using grid-tied inverter, we can use this DC power, DC solar power as AC in our grid line. And it can also be connected to the AC 220 volt bus to serve the 220 volt AC outlet. And we also proposed here a 120 volt DC bus. To power up this, we use AC DC converter. It is actually used to convert 220 volt AC grid power to DC power. And we can get DC voltage from DC actual power from the solar panel, and this can be gone through the DC-DC converter to 120-volt DC bus connection. And this 120-volt DC bus serves power to 120-volt DC outlets of the distribution system. And from 120-volt DC bus, we can use DC-DC converter separately to serve 5-volt DC and 48-volt DC outlets. And here in the methodology section, we present our sensor functions and the data process flow. We have LDR sensor, that is light dependent resistor, humidity sensor, temperature sensor, and human presence detection sensor. And we have also on board processing unit for each sensor to detect and determine the sensor's data. Such like from LDR sensor, the data is processed and we determine here the light intensity. And from humidity sensor and temperature sensor, after processing the data, we can the processing unit can actually estimate the filling of the temperature and determine the filling of the temperature. And from the human presence detection sensor, after processing the data, the sensor the processing unit can determine the human presence. And this outcome of the processing unit are transmitted to the processing data center that is in the ThingSpeak IoT server. And the data is then here processed to actually carry out the control signals for the home appliances. And then some for the visual representation, the processed data is also represented in ThingSpeak server dashboard. The data can be stored in a memory for further use also. And here the result and analysis section, we demonstrated here some simulation result. Like AC-DC combined socket simulation by MATLAB Simulink is presented here for 220-volt AC, 120-volt DC, 120-volt DC, 48-volt DC socket, and 5-volt DC socket. The visual representation of the data of a 48-volt DC socket is demonstrated in ThingSpeak dashboard and attached here for a sample. Here in the top left window, we can observe voltage level of the 48-volt DC socket. At top right, it is current which is consumed by the connected load. At the bottom left, the power consumption is illustrated. And at the bottom right, the status of the connected load is illustrated as switch on or off. And some and the other outlets like 5-volt DC, 48, 120-volt DC, and 220-volt AC can also be represented like at this dashboard. The conclusion, we want to conclude as a combined power distribution socket with a smart control system to convert traditional homes. The smart home is proposed in this paper, and AC voltage of 220 volt and DC voltages of 5 volt, 48 volt, and 120 volt are combined to distribute the power appliance. A simple rule-based algorithm is developed to control the devices. 4 sensors, namely HDR, humidity, temperature, and LDR are used. The control algorithm can be implemented to avoid energy waste, including standby energy losses for electrical home appliances. In the future scopes, we can have actually some of the scopes, like our plan is actually to develop this primary design to develop this primary design to more efficient and feasible system. Utilizing the received data from the sensor and appliances, a predictive model can be developed. A neural network model can be trained, and this model can be trained to predict the demand of household appliances for better demand response. Further, solar power generation is subject to solar irradiances, and the irradiation is actually intermittent. Further, solar irradiation remains most at off-peak time when the household demand is lower. The net metering system has become the only way to exploit the generated power by exporting to grid, hence increase the grid instability. So a predictive model can be used with integration of energy storage system to ensure 100% solar power consumption rather than exporting to grid, hence reducing the possible intermittency in the grid. And we have come to the end of this presentation. Thank you for your kind attention.